Our dynamics practice unit test, question number 1 says the force of friction acting on an 1,800 kilogram car. The driver brings the car from 100 kilometers per hour to rest over a distance of 40 meters. When you have a test, you will have a paper copy of the test, right? Which is like you do on a quiz, which means that if it's me, I'm going to draw attention by circling in red or highlighting or something, things like this, kilometers per hour. Why do I want to draw attention to that? Why is that important, Ethan? We want to be, yeah, the distance is in meters, yes, but besides the distance being in meters, okay, even if I wasn't given a distance, I'd still want to convert that to meters per second, right? The only time that you can leave it as kilometers per hour is if you're using v equals d over t. Okay, clearly there's more to this question than just v equals d over t, so I need to be in meters per second. If it is just a v equals d over t question, and I promise you on your test on Monday, you will not get just a straight v equals d over t question. But if down the road you do get something like that, then yeah, you can leave it in kilometers per hour. But that doesn't happen very often, certainly not anymore, right? We're always dealing with acceleration and so on. All right, so what do we do here? We want to find the force of friction. Here's what some people wanted to do. F is equal to, the force of friction is equal to mu times the normal force. I've always told you, okay, I've always told you, try something valid. This is something valid. Okay, you're allowed to try this. You're not going to get the wrong answer as long as you're using this equation, as long as you don't use it improperly. The problem is, I don't know what mu is, the coefficient of friction is. So I don't see a way to use this equation to find the force of friction. It's valid, but you don't know F, and you don't know what mu is. So I don't think it's going to work for us. The other way to find force of friction, or any force for that matter, is what? Assuming there's only one force acting, the way to find that force is always F is equal to m times a. So I'm going to do that. Right? If F is equal to mu times the normal force doesn't work for me, then let's try something else that might work for me. I'm going to try F is equal to m times a because that's valid for finding friction or any other force for that matter. Now, I don't know what a is. Okay, last time I didn't know what mu was. This time I don't know what a is. But I think a is going to be a little bit easier to find here so that we can sub it into there, right? Mu, I didn't see another way of finding that to sub it in. A, I do. For a, what do you want to do here? Some people tried this, v equals d over t. Okay, you've got you've got v, and you've got d, so you could solve for t, and then somehow find acceleration from t. Does that make sense? Okay, what's wrong with that? Besides the fact that it should be delta d over delta t, actually not just d over t. What's wrong with that? Why can I not use v equals delta d over delta t? V equals delta d over delta t is a, what type of equation is it? Group A. What do we got here? This is accelerating, right? It's slowing down. So this is a group B problem. We cannot use that equation, even if it looks like it fits. What I would do, I think, is try this one. Vf squared is equal to vi squared plus 2ad, and solve for acceleration that way. Vi is 100. It comes to rest, so Vf is 0. So we're going to say 0 minus vi squared equals 2ad. Right, take the vi squared over by subtracting, and then let's take the 2d over by dividing. It becomes negative vi squared over 2 times d equals a. Now, let me see on my answer key. I just did kind of a chicken scratch answer key, but let me see if I have that value there. I do. Negative 9.645 meters per second squared, which I now am going to sub into here along with the mass, and I'm going to get a value for the force of negative 1.74 times 10 to the 4 newtons. By the way, we circled this kilometers per hour because we remember we have to convert to meters per second, and to do that we would multiply by 1,000 and divide by 3,600. I think it worked out to be 27.778 meters per second, right? Which is, of course, the value we have to use in there for VI. Okay, does that make sense? That was only out of 2 points. On the assignment, we usually make things out of 2 or 3, depending. On a unit test, it ends up being a little bit more because in the unit test, I give you more opportunity for part marks. Okay, the unit assignment is basically it's it's a 2 or it's a 1 or it's a 0 probably. But this is probably a 3-point question on a test. So you got a little bit more opportunity for part marks on the test. Show that work because there is more opportunity for part marks. Okay, 2 says a 2.3 bag of candy is pulled to the west with a force of 12 newtons and to 30 degrees south of east with a force of 50 newtons. What's the net force acting on the bag of candy? Now, a number of people misinterpreted this question. This is not a wagon question, right? When we're pulling on a bag of candy from 2 different directions, that bag of candy is going to go in some crazy direction, right? This is not going to be, you know, I pull on the bag of candy like this, I pull on the bag of candy like this, it slides horizontally along the floor, right? When we're pulling a wagon like that, sure. When we're pulling a bag of candy in different directions, it's just going to go in some kind of crazy direction. So what we got to do first is draw a diagram. Here's my 2.3 kilogram bag of candy. I'm pulling it this way, we'll call it F1 of 12 newtons, and I'm pulling it this way, we'll call it F2 with a force of 15 newtons. And our angle here is 30 degrees. We got a funny angle, we got to get rid of that funny angle, so we take it off to the side here. We got 15, this is X, this is Y, and this is 30 degrees. Using the cosine function, the X component ends up being 12.99, and the Y side, the opposite side of the triangle ends up being, what is it, 7.5. So we kind of box that off to the side here, and then we do our X and Y components. Some people did this and then just essentially did an X component by saying F net is equal to the sum of the forces and completely ignored the Y component there. So what do we get for the first one is negative 12. For the Y component is 0. For the second one it's 12.99, and the Y component is negative 7.5. Add these up, 0.99 and negative 7.5, and then we combine them, 0.99 and 7.5. Make sure, please, make sure that you show your work. Okay, there's too many people who got into that lazy habit of just doing things on the calculator. Make sure you show your work. We want to find the value of R, 0.99 squared plus 7.5 squared. Show this on a test. Okay, theta is equal to the inverse tan function of opposite over adjacent, 7.5 over 0.99. We do this. For R, we end up getting 7.6 newtons. And for theta, we end up getting 82. Let me see here. We didn't need the mass, did we? So that shouldn't be 7.6. It should be 3 digits because we didn't use the mass. We're not paying any attention to that. We're looking at this, looking at this, looking at this. Final answer should be 3 digits, right? I have it rounded to 2 on my answer key. What is it to 3 digits? 7.57? Oops. Sorry? Yeah, I've got, for whatever reason, I've got the angle in 3 digits, although I've got 82.5. What did you guys get? 82.5? Okay, so that must have been some rounding thing somewhere. 82.5 degrees south of east, or it could have been like 7.5-ish degrees east of south, right? By the way, I didn't take off marks for significant figures here. Okay, I keep telling you I will. I promise on Monday I will. Promise on Monday I will. Although having said that, like we'll max it out. So if you mess up on significant figures through the whole test, like, you know, I'm not going to take a mark off on every question. We'll max it out at, you know, 2 or 3 points. But still, like, you don't want to lose 5% of the test because of 5 or 10% of the test because of significant figures, right? Okay, 3. Coefficient of, this is a really well done question, actually. Really well done. The coefficient of static friction between a 10 kilogram block and the force 0.6. Kinetic friction is 0.4. What's the force of friction? Well, we need to know what the maximum force of friction is, right? FSF max. It's equal to mu times the normal force, which is 0.60 times 10 times 9.81. That gives me FSF max of 58.86 newtons. All right, If I apply a force of 20 newtons, it doesn't move. So then my static friction would just be 20 newtons. If I apply a force of 50, it doesn't move. So static friction would just be 50. If I apply a force of 80, it does move. Now I've got to find the force of kinetic friction. When I do that using the other coefficient, I get a value of 39.24. All right, so if I apply a force of 80, it's kinetic. And what's the force of friction? 39 newtons. If I apply a force of 100, it moves. It's kinetic. Okay, what's the force of friction? 39 newtons. If I applied a force of 10,112, then it would be kinetic friction, and the force of kinetic friction would be 39 newtons, right? Good. By the way, question 2 is worth 3 points because there was the more vector analysis there, so I weighted that a little bit heavier. Question 3, back to 2 points. Basically, I assumed that if you calculated this and this, you're probably going to get all these ones right. 4. The coefficient of kinetic friction acting between the bottom of a 10 kilogram box and the floor is 0.30. Box is pulled to the right with a force of 75 newtons. What's the acceleration of the box? So we're pulling it directly to the right here with 75 newtons. That's FA. And we've got friction that's going to act to the left. We'll call that FF. Let's get the value of friction here. Mu times the normal force. Coefficient is 0.30. Normal force is m times g, 10 times 9.81. When is the normal force in a problem like this not m times g? Like when is the normal force something other than equal to the force of gravity? This ends up being, right, when we do the math here, this ends up being 29.43. If the normal force is not the same as gravity, then the force of friction will not be 29.43. What would happen if I had a situation like this? Would the normal force be m times g then? No, it wouldn't. How would I find the normal force then? Not quite. Well, you're not that far off. You're on the right track. The normal force and the y component, combined with, the normal force combined with the y component would cancel out gravity. So the downward force of gravity would cancel out the normal force and the y component. So you'd know gravity, m times g, you'd know the y component, or you'd calculate the y component, and then you'd figure out the normal force and then sub it into there, right? If you were doing this, had a situation like this, almost the same thing, but this time it would be gravity acting down plus the y component would equal the upward normal force. So the total upward equals the total downward if it's just moving horizontally. Solve for the normal force and then sub it into there if that situation arises. All right? Make sense? All right, so we got the applied force, we got the force of friction. Let's just do our thing now. F net is equal to the sum of the forces. FF plus FA. We're going to say m times a. M is 10 kilograms times the acceleration equals negative 29.43 because it's to the left, plus the applied force of 75 newtons. We're going to solve for a here. Do the math. It works out to be 4.5, I think it's 4.56 or 4.50. 4.56? Yes? Can't tell whether my last number is a 6 or a 0. Don't forget your negatives, right? Don't forget your negatives. Watch out for the fact that, for the possibility of maybe the applied force being upwards like that, a wagon type problem as opposed to a straight x component problem here. Okay. 5. The acceleration of the box below, assume a 25 Newton force of friction acting on box B. So what do we got here? We got, I'll call this FA acting down. We'll call this FC acting down, which is smaller than FA. Which way is friction going to act, left or right? It's acting to the right. Okay, it's acting like this because it's going to move to the left or Object A is going to move downward. Object B is going to move to the left. Friction has to act to the right here. I want to straighten this out. Okay, that's what I always do with this. This is 15. Okay, this is 5. This is 8. We got a FA acting this way. And we got an FC acting this way. And we've got an FF acting this way. When I draw it out like this, it makes it a lot easier to determine what's positive and what's negative. We're going to say F net is equal to FA plus FF plus FC. FA, by the way, has a value. It's 15 times 9.81, so it's going to be 147.15. What mass do I use on the left-hand side here? 15, 5, or 8? 28. Use the total mass, right? 28 times the acceleration is equal to negative 147.15 because it's to the left. Friction is positive 25 because it's to the right. And FC is 8 times 9.81, which is 78.48. And it's positive. Despite the fact that it's gravity, it's positive because in my diagram up here it's acting to the right. FA, left, FF, right, FC to the right, negative, positive, positive. Combine those terms, divide by 28, and we get an acceleration here of negative 1.6 meters per second squared. All right, number 5 is a good question to ask you this on. What type of question is conspicuously absent from this little practice test? What type of question did I miss, did I err in not putting on this practice test?
Where you're finding the tension.
Yeah, where I'm finding the tension. Now, that doesn't mean that you will or you will not see that on your unit test. But I'm just warning you that that was not intentional, me leaving that off. It just was an error on my part in leaving off a tension question on this. So you may or may not see a tension question on the test on Monday, but make a note on your assignment here, especially if you're going to go back and refer to that assignment when you're studying for your test. Make a note that you need to be able to solve for the tension in the rope here, okay? How would you solve for the tension in the rope? I won't go through the whole thing. I won't do the whole thing, but how would you solve for the tension in the rope there if you were asked, Venture?
After you analyze the whole system, you just focus on one.
Right. We've just analyzed this whole system, right? That's what you got to do first. Even if it did ask you for the tension in the rope there, you'd find the acceleration, analyze the system. And then you pick an object, like either the A or the C, depending upon which tension you were trying to find. Let's say we're trying to find this one. Then we'd probably analyze object A. That would have FA this way, 147.15. And we would have FT, the force of tension, this way. And then we would just do our thing again, except with a 15 kilogram mass instead of a 28 kilogram mass, right? So be ready for that. Hey, it may or may not appear, but at least it's fair game. And I didn't want to, kind of sucker punch you on Monday with a tension question, conceivably, without having either put it on here or reminded you of that possibility on there. All right, 6 says, what's the work done on a 1,500 kilogram car and accelerating it from rest to 30? The force is 3,000 over what distance was the work done? Here's what I want to do to find work, although there is another way to find work as well, and both would be marked correct because you should get the same answer both ways. I'm going to say work is equal to the change in energy. And the change in energy is, well, if it goes from rest to 30, the final energy would be kinetic energy, and the initial energy would be 0. Agree? So let's find that work there by essentially finding the final kinetic energy. It's 1/2 of 1,500 times VF squared. That gives me a value for work of 6.75 times 10 to the 5 joules. And then once I find that, what I'm going to do to find force is just say F times D. Rearrange this to solve for force. I get work over displacement. It ends up giving me 6.75 times 10 to the 5 divided by the displacement of No, wait. What am I doing here? What did I do wrong? What am I looking for? Not force, right? But displacement. So it should be this. Divide that by the force of 3,000 newtons, and that gives me a value for the displacement of 225 meters. All right? Now, how many people got the right answer for this, but yet did it differently? Nobody? Everybody did it this way? All right, well, there is another way to do it. What we could do is say F is equal to m times A. Rearrange it to solve for A. Now, I don't know what that works out to be because I didn't do it this way, okay? But you could, right? You got the force, you got the mass, you could solve for the acceleration, agree? Now, once you find the acceleration, you could say Vf squared is equal to Vi squared plus 2AD. You've got Vf, it's 30. You got Vi, it's 0. You've got A now, whatever that worked out to be, and you'd solve for D. Well, then we just solve for the second part of that question, right? Then once we solve for the displacement, which would have worked out to be 225 meters here, then we could turn around and multiply the force that was given to me of 3,000 newtons times the displacement of 225 meters, and we would have gotten the work of 6.75 times 10 to the 5. Nobody did it that way? Everybody did it my way? Well, there you go. My way must be the best way then if everybody's doing it my way. Okay, good. I like the way that I did it better. I like the way that you did it better than the other way. Okay, but the other way is a legitimate way to tackle it as well. Okay, number 7. 7 that wasn't, no, sorry, 7 that we did have to do. It was 8 that I told you not to do because we hadn't at that point finished that material. 7 says a 30 kilogram box slides down an incline at 30 degrees. It's resisted by a force of friction. What's the acceleration? Here's my 30 kilogram box. There is a force of friction acting up the hill. It's 32.0 newtons. We've got force of gravity acting this way. We've got the normal force acting this way. And remember that F parallel is always parallel to the hill and is always perpendicular to the normal force. So we find F parallel, and for the most part, people that made a mistake on this question made a mistake on calculating F parallel. We know this angle is 30 degrees right here. We're going to say sine 30 degrees is equal to F parallel, that's opposite, over hypotenuse. So F parallel ends up being equal to 147.15. Now, I've actually got FF drawn too long there. It should be shorter than that, right? Because it's 32 newtons, and F parallel was 147. So FF should be drawn way shorter, actually. Well, now we just do our thing. F net is equal to the sum of the forces, F parallel plus FF. The net force is 30 times A. F parallel is negative 147.15, and FF is positive 32 newtons. A ends up being equal to, these combined divided by 30 gives me negative 1.6 meters per second squared. Okay, negative because it's down the hill. If you had positive 1.6, then it was probably because you made F parallel positive and FF negative. Is that okay? Sure it is. Sure it is, as long as you're consistent in the question, right? If down is negative, and up has got to be positive. If down is positive, then up has got to be negative, right? And finally, number 8. This is almost like one of the questions on your assignment that you're going to have to complete in 2.5 weeks when we have our amusement park field trip. Sorry, thank you, Tino. Everything is right here, but I just copied down the wrong answer for that from another question. In question number 7, the answer is negative 3.84 meters per second squared, right? Thank you. Negative because I've got down the hill defined as negative. Could be positive if you had down the hill defined as positive. All right, and finally, number 8, which again is very much like one of the questions you're going to get on your assignment in 2.5 weeks when we do our amusement park field trip. one of many questions that you're going to get on that assignment. The first hill on the Mindbender roller coaster, West Edmonton Mall, is 50 meters high. If a 1,000 kilogram roller coaster car, including the mass of its passengers, by the way, that's actually light. That's actually light. 1,000 kilograms is lighter than it would be. You figure if every person on the roller coaster has a mass of between 50 and 75 kilograms, then in one cart, the people are going to have a mass of probably upwards of 300 kilograms, right? And the roller coaster cart itself weighs somewhere in the range of 1,000 kilograms. So we're going to be dealing with a mass of a single roller coaster cart that's actually a fair bit more than 1,000 kilograms. Anyways, we're going to say that for this question. 1,000 kilograms begins at the top of a hill, 50 meters high, not 5, but 50 meters high. Goes down the hill from an initial speed of 5.00 meters per second. We want to find out how fast it's moving at the bottom of the hill. What do we do here? This is like what we did yesterday, right? What do we do here? Megan? Good. It's the law of conservation of energy, right, which says the total energy is going to remain constant. In the absence of outside forces like friction, okay, air resistance, the total energy is going to remain constant. What kind of energy do we have at the beginning of this problem? We've got a height, so there's potential, mgh. Is it moving? Yes, so there's kinetic energy as well. Now, when it reaches the bottom, when it reaches the end of the problem, does it have a height? No, it doesn't, so there's no potential. Is it moving? Yes, so it's got kinetic energy. So this is what my equation is. What's my shortcut? A little bit of a shortcut, right? Cancel the masses. So this is, we're telling you that you get on a roller coaster in 2.5 weeks for your assignment, and you don't have to worry about whether the seat next to you is empty or whether there's a 300-pound person in the seat next to you. It's not going to affect anything because the mass cancels out, right? Does that make sense? You're not going to be going faster at the bottom of the first hill because there's a big guy next to you versus an empty seat next to you. All right, let's sub in our numbers here. G is 9.81 meters per second squared. The initial height is 50 meters. 1/2 of 5.0 squared equals 1/2 of VF squared. Let's get the left side here. 9.81 times 50, I think is 490.5. 5 squared is 25 times 1/2 is 12.5. Add those together and we get, what, 491, 501, 503. How do you take the half over? You can either times it by 2 or you can divide by 1/2, divide by 0.5. Either way works, gives you the exact same thing. That gives me 1,006. And then I'm going to, of course, get rid of the squared by square rooting. And the square root of 1,006 is, what is it? 31.7? And there we go.